Introduction. Integration is a key concept in calculus that involves finding the integral of a function, which can be understood as the process of accumulation or the area under a curve. There are two main types of integral. Definite integral, which calculate the exact area between the curve and the x-axis over an interval, and indefinite integral, which provide a general form or antiderivative and include a constant of integration. Integration have wide-ranging application in various fields, such as physics for calculating displacement and work, engineering for analyzing signal, and economic for determining consumer supplies.
As for the rules and formula, I have listed out some of the basic integration rules, which are: when we integrate 1 dx, it will give us x plus c. And if we integrate xn dx, it will give us xn plus 1 over n plus 1 plus c, where n cannot be equal to 1. And also, when we integrate sine x, it will give us negative cos x, and if we integrate sec 2x dx, it will give us tan x. As for this question, the method used is the separation of variable, where the method of separation of variable is a powerful technique used to solve differential equation, including second order kinetic equation. In the context of second order kinetics, let's consider the general form of the differential equation, which is delta A over delta T equals to negative K times A power of 2, where A is the concentration of the reactant, K is the rate constant, and T is the time. So for the solving steps of the problem, at first we have to separate the variables from the second order rate law, and then we have to integrate both sides, which gives us from the left hand side negative 1 over A, and the right hand side negative KT plus C. After that, we have to solve for the constant C by substituting T equals to 0 and A equals to A0, which gives C equals to negative 1 over A0. And then we have to substitute the C into the general equation, which gives us 1 over A equals to KT plus 1 over A0. Therefore, rearranging the equation gives us the value equation for the A, which is 1 over KT plus 1 over A0.
Okay, next is general use of integration. So basically, there's a lot of function that can be used in integration in our daily life, in our real life. So I picked two examples. So first, integration are basically used in engineering and finance. So first, let's go through to the engineering. Integrals are used in structure analysis and signal processing. For structure analysis, engineers use integrals to calculate the center of mass, moment of inertia, and stress distribution in structure. For signal processing, integrals help analyze signal in both the time and frequency domains. Okay, second example of use in integrals is finance. So finance, present and future value. So integrals calculate the present and future values of continuous cash flows. So second is risk assessment. So integrals help in pricing complex financial derivative and assessing risk. So this example shows how integrals are essential in analyzing and solving real-world problems across multiple disciplines.
Integration in chemistry. One of the main use of integration in chemistry is in NMR spectroscopy. The integration in NMR tells us the number of protons represented by a given signal. To be more accurate, let's mention that it is the ratio of the proton behind each signal. From the above diagram, the height of each integral is proportional to the area of the given signal, and the area is determined based on the number of absorbing protons. The integral of signal B is 1.0 1.5 times taller than the one for signal A, since the proton ratio is 3 to 2. On the second spectrum, the integral of signal A is 6 times taller than signal B, since the ratio here is 6 to 1.
So for our question, we got the question 8, which is second order chemical reaction, which given the rate of loss of A is expressed by second order kinetic equation below, which is dA over dt equals to negative K A squared. We need to obtain the equation which will give us the concentration of A by using the T equals to 0 when A equals to A0 to a general time T equals to T when A equals to A0. So the solution we get for this question is to write down the dA over dt equals to negative K A squared, and then we switch the position of A squared and dt. A squared to the left and dt to the right. And then we integrate both sides with A0 and AT. So in this integration, we get 1 over A squared with dA from the left. So we will bring the A squared to the upper tier, and then it will change to A powered by negative 2 dA. And then we integrate both sides, and we will get A powered by negative 1 over negative 1. And then we need to insert the AT and A0 on the left side, while on the right side we will get negative K T and insert the T and 0. And after we insert the A0 and AT, we will get on the left side negative 1 over AT minus negative 1 over A0. And on the right side, negative T is what remains. And when we multiply the whole equation with the negative 1, and we will get 1 over AT minus 1 over A0 equals to KT, which is the equation which will give us the concentration A.
Conclusion. In conclusion, integration is an ancient mathematical tool that play a crucial role in understanding and solving problems involving accumulation and area. It bridges the gap between differential and integral calculus, allowing us to compute areas, volume, and others quantitative and accumulate over time or space. With application spanning numerous fields, including physics, engineering, economics, and statistics, integration not only aids in theoretical exploration but also provide practical solution to real-world problems. Understanding integration empower us to model and analyze continuous change effectively, highlighting its significance in both academic and applied contexts.